So here we have the function f of t equals to 2 raised to the power of t. So we need to determine the Laplace transform of the given function. Now, what we're going to do, well, we're going to change this given function. So we're going to use the property that e raised to the power of the natural log of x. So that means natural log means the base is e is actually equals to x. So that means 2 raised to the power of t can be written as e raised to the power of log of 2 raised to the power of t to the base of e. So that gives us e raised to the power of, so we are again using the property that log of a raised to the power of b is equals to b times log of a. So we have e raised to the power of t times log of 2 to the base e. Now we can apply the Laplace transform to 2 raised to the power of t, which is equivalent to saying Laplace transform of e raised to the power of t log 2. So we know that Laplace transform of e raised to the power of a times t is 1 over s minus a. So if we look at this particular function, so we have t times log of 2, so that means our value of a is log of 2. So that gives us 1 over s minus a. So a here is log of 2, or the natural log of 2. So this is the given Laplace transform for the function, which is going to exist when the numerator s minus log of 2 is greater than 0, or we can say s is greater than the natural log of 2. Let us do another problem. So this problem is very much similar to the previous one, except for the fact that instead of 2 we have 3. So we can rewrite it as e raised to the power of the log of 3 raised to the power of t with base e, or we can simply say this is simply equals to e raised to the power of t times log of 3 to the base of e. So Laplace transform of 3 raised to the power of t will be equals to Laplace transform of e raised to the power of t times log of 3 to the base e, which will give us 1 over s minus log of 3 to the base e, which is the required Laplace transform, and this transform is going to exist for s greater than log of 3 to the base of e. Let us do another problem. So here we have the function 4 raised to the power of 3 times log of t to the base of 4. So here we can do is we can rewrite the given function as 4 raised to the power of log t raised to the power of 3 with the base 4. So here we have applied the property that a times log of b is equals to simply log of b raised to the power of a. And we have the other property that a raised to the power of log of b to the base of a is simply equals to b. So since the 4 and the base of the logarithmic function is are equal, so that means this will be equals to t cubed. So Laplace transform of 4 raised to the power of 3 log t to the base 4 is the same as finding the Laplace transform of t cubed. So we know that Laplace transform of t raised to the power of n is simply given by n factorial divided by s raised to the power of n plus 1, where s is greater than 0 and n is a natural number. So here we have t cubed, so 3 being a natural number, so this will be equals to 3 factorial divided by s raised to the power of 3 plus 1. Now 3 factorial is equals to 6, so we have 6 divided by s raised to the power of 4. So this is the required Laplace transform for the given function, which is going to exist for s greater than 0. Let us do another problem. So we have the function negative 3 divided by square root of t, and we need to find its Laplace transform. But before that, what we're going to do, we're going to simplify this given function, so we can rewrite it as negative 3 divided by, so square root of t can be written as t raised to the power of half. So we take it to the numerator, so that will be negative 3 times t raised to the power of negative half. So Laplace transform of the given function f of t will be equals to Laplace transform of -3 times t raised to the power of -half. Now -3 is a constant, so we can pull it out of the operator. So we have -3 times the Laplace transform of t raised to the power -half. So that gives us -3 times, now we have t raised to the power of -half. So -half is a rational number. So we use t raised to the power of p. So Laplace transform of this function, where p is a rational number, is given by gamma p plus 1 divided by s raised to the power of p plus 1. So p is a rational number. So that will be gamma -half plus 1 divided by s raised to the power -half plus 1. So we get -3 times gamma -half plus 1 will be +half divided by s raised to the power of half. Now we know that gamma of half is equals to square root of pi. So that gives us -3 times square root of pi divided by square root of s. We can say it's simply -3 times square root of pi over s. So this is the required Laplace transform, which is going to exist for the value of s greater than 0. Let's move on to the next question. So here we have the function a raised to the power of t plus t raised to the power of a, and the value of a is a positive number. So we have to find the Laplace transform of the given function. So what we can do, we have to change the first term of the function. So we have a raised to the power of t. So that can be rewritten as e raised to the power of log of a raised to the power of t with the base of e. We don't change the second term, so let's keep it the way it is, t raised to the power of a, which will be equals to e raised to the power of t times the log of a to the base of e plus t raised to the power of a. Now we apply the Laplace transform to the given function. So we have Laplace transform of f of t. So that will be equals to Laplace transform of e raised to the power of t times log of a to the base e plus the Laplace transform of t raised to the power of a. So this will be equals to 1 over s minus a. So a here is log of a plus Laplace transform of t raised to the power of a. So here a is, it's only mentioned in the question that a is a positive number. So a could be any real number. We can say it could be a rational number, it could be a natural number. So we are going to assume that it is a real number. So that means we have gamma a plus 1 divided by s raised to the power of a plus 1. So this is the Laplace transform of our function for value of s greater than log of a to the base of e.